So this is going to be a long video. This is about the scalar product of two vectors, which is often called the dot product. It's called the dot product because it has a dot. We say A dot B. It's called the scalar product because our answer is a scalar, that is a whole number answer. We're not getting a vector. We're multiplying two vectors together. We're doing vector times vector, and we're ending up with a scalar that is a whole number answer. Now, the rule here, A dot B equals the magnitude of A times the magnitude of B times the cosine of theta, where theta is the angle between A and B. So have a look at my picture here. I put, here's vector A, here's vector B. I'm talking about theta is the angle between vector A and vector B. Notice they have to start at the same point to work out that angle. So you can move the vectors around in space to get that to happen. Now, here's a few important points. First of all, A dot B equals B dot A. That should be a vector A vector A. Here's the distributive law, A times B, so that becomes A dot B plus A dot C. So you can use your normal distributive law. This is important, number 3. If A and B are parallel, vector A and vector B are parallel, then the angle between them is going to be 0, which means the cos of 0 is 1. Therefore, A dot B, if they're parallel, will equal the magnitude of A times the magnitude of B. If vector A and vector B are perpendicular, that is, they're at 90 degrees to each other, then the cos of 90 degrees is 0, so A dot B is 0. This is a very useful and important way of finding out whether two things are perpendicular. Number 5, I dot I, J dot J, and K dot K. Obviously they're all parallel to each other. I is parallel to I, J is parallel to J, K is parallel to K, equals 0. Now if you have two non-zero vectors, A dot A, then they're going to be parallel. Their dot product is going to be the magnitude of A squared. So the magnitude of A times the magnitude of A. In terms of I, J and K, what do we do if we have these vectors and we want to work out the dot product? Well, it's just multiply the two together. x1 times x2 plus y1 times y2 plus z1 times z2. And that will give us our dot product. Let's put that into an example here. Let's find the dot product, A dot B. Well, A dot B is going to equal 4 times 3 plus 3 times minus 2 plus minus 5 times 1. What does that give me? 4 3s are 12, minus 6 minus 5. So A dot B in this case equals 1. Now let's find the angle. Our original rule said that A dot B equals the magnitude of A, the magnitude of B times cos theta. So cos theta equals A dot B all divided by the magnitude of A times the magnitude of B. I'll put that in. We've just worked out from our previous example that the magnitude A dot B equaled 1. The magnitude of A, 3 squared plus 2 squared plus 1 squared. and we're going to times that by the magnitude of b, which is 4 squared plus 3 squared plus 5 squared. What does all that come out to be? That's 1 over square root of 14 times the square root of 50, which becomes 1 over square root of 700. That's cos theta. Theta is the inverse cos of that. Inverse cos 1 over 700. That's a calculator job. That gives me 87.8 degrees. So we found the dot product of two vectors, and we found the angle between two vectors. Our next video will look at linear independence and scalar resolutes.